Right, hi everyone, welcome to my YouTube channel, and this video we're going to talk about this project 1 of the Arduino project handbook, push button controlled LED. And of course, in this project we will just add a push button switch to an LED circuit to control when the LED is lit. So this is kind of the final product, final design or final connection. Whenever you push this button, you will get the LED will turn on. Alright, so let's get to work. Now, of course, we'll need, let's bear in mind, input, process, output. We'll be working with that mindset. So what do we need for the inputs? What do we need for the inputs? We'll need the push button to give us inputs. Here we have it, push button, which is momentary switch for a moment. So you see the button here. Okay, that's the button. Now if you look at it, you see there are 4 pins, and if you look here, you will see that the pins are even separated here. So you see these 4 pins, look at this to this part, this is 1 pin, 1 2 3 4, yes. However, what we have there is actually 1 coming out from this end, the same 1 coming out from this other end. Similarly for this side, 1 coming out from this end, the same 1 coming out from this end, meaning we have 2 metals, okay, 2 conductors, 1 2, but 1 is showing out of 1 2, the other one is also showing out from 1 2. So it looks like 4 pins, but they're actually 2. Okay, so meaning whatever you connect here is also linked to this part. Whatever you connect here is also linked to this part. When you look at this, you see something like this now. This black, I know this whole thing is black, but it's a black in between. That thing tells you that this guy is separate from this guy. Okay, so we'll connect this, and then anytime we push this button here, anytime we push that button, that is when both sides will be connected. Okay, so once we push that button, I'll show you how we do the connection. So we'll need this guy, we need it. Okay, there we have it. All right, on the other side. Okay, and we also need so this serve as the input, and then the part that will do the processing, of course, that will be the microcontroller, do the processing. The microcontroller will do the processing. Okay, so this guy will serve as our processor. Then what else? So we have input, process, and output will be the LED. Let me get an LED. Okay, light emitting diode serve as our output. Now, but like I said, to protect the output, we use what? Resistors. We use resistors. Now 220 kilo ohm resistor, so that it will protect it, and at the same time allow, not protect too much, not resist too much current, so that we can still see something. We can still see output signal in the LED. Okay, so we have that, and then what else? Of course, breadboard to hold the components in place when we do our connection, and then of course jumper wires. Okay, that's kind of too much, but you get the point. Now I place only just 1 resistor here. I will introduce another resistor, but when we need it, I will introduce it. Okay, now let's make our connection. So our connection will be in this format. I think I just need to zoom in. Okay, all right, I think that's clear enough. Now what we want to achieve is that anytime we push this button, the LED will turn on. Okay, so let's connect the LED somewhere. Of course, this is the positive. Longer side is longer side is positive. This side is negative. So yep, real human hands. So I finally took out my gloves in this video because I observed that the whole thing was getting, sweaty, and so I just washed my hand thoroughly. Then, okay, of course, dry them. This guy is drying off. Nice hands. All right, so let's make the connection. So longer side of the LED. Where are you? Longer side. So let me just connect it somewhere. Let me use the edge. Connect it somewhere. Put it somewhere, and then to the positive leg or the positive side, connect a resistor. Hope you can see that, guys. Let me just put this thing on the table and really zoom in. So on the positive side, I connect a resistor. Here. Okay. Now, after doing that, I can now connect from pin 13 in this guy in the Arduino. Where's my pin 13? Pin 13. Okay, connect pin 13 to where we have this guy here, where we have the LED is right here, so we can put it here. So what I've just done, I connect this pin 13 to this LED, and to the resistor, and from the resistor to what? The positive of the LED. It's just like saying I'm connecting from pin 13 to the LED, but I put a resistor in between. And then I will connect from the LED, that's the negative leg, to where? To ground. Which is let me just put it to the negative rail, which is this one, to the negative rail. But of course, there's no ground to it now. So what I will do, I will connect from the Arduino ground. So let me use a longer one. Connect this ground. Can we see that? Connect the ground here. Okay, to to the Arduino ground, which is, if you look at it, you will see GND. So I'll connect it to any of them there. So let me just put it here. Okay, I can actually use this other ground here. There's one ground there, but no big deal. So this guy now is connected. If we power this thing now, this guy is supposed to light up. Okay, it's supposed to light up, but let me just continue with what I'm doing. So that guy is connected. Now we have to connect. So this guy now, pin 13 will serve as output pin. Fine, but we want to use this one as the input. Meaning, if we push this one, signal will go into the Arduino, the microcontroller. We'll now say we'll now write in the program that if there's a signal in this pin, then turn this one on. Okay, so remember when we did blinking the LED, we just blink the LED without any condition. But now we want to put a condition saying if we have input signal from this one, then this one should turn, and they will not turn this one on. So we are going to connect this guy. Let's just put it, I think we're supposed to put it across. Anyways, let me just put it somewhere. Across will be better. Yeah, across will be better. Okay, because it's not really holding like that. Let me put it across. Okay, we there? Yes, fixed. Yep, it's fixed. So what's going to happen now is this. We are going to connect this. I'm not giving the Arduino in the live. So let me power. This is the negative rail. That's the negative side. We've done that, connected to the negative of the to the ground of the Arduino. So let me also sorry. Let me also connect if you have it in mind to buy me a camera, you can please do so. Okay, thank you, and I appreciate. Okay, let's continue. So let me connect the 5 volts of the Arduino, which is the positive, to this other side, which is positive also, making here positive. Okay, making here positive. Now since that is done, I believe you can see what's going on. We can now connect this one, from this positive to one side of the switch of the push button. No, sorry, it should be here. Yeah, that's where it is. To one side of the push button. Okay, so now look carefully at what I want to do now. Then I will connect the other side of the push button. Connect the other side of the push button. Enter. Connect this other side of the push button to where? Let me just use pin 3. Oh, pin 3 has a pulse width modulation function or capability. Yeah, so let me use pin 2. Okay, use pin 2. Now pin 0 is for ROX, which is receiving. Then pin 1 is for transmitting. So we start from pin 2. Now that transmitting and receiving, don't worry about that one for now. When we get to projects related to that, we'll do it. So now look at this thing now. In this case, now we see that this live of the Arduino is now connected to one side and then connected to pin 2. So if you press this one now, it means we now have a signal flowing into this pin. Are we seeing it? If I don't press it, there's no signal flowing. If I push it down, there is signal flowing into it. So if now we can write in the program saying if we have signal here, then turn on this one. Then we'll now send output to it. So this pin will serve as input, this pin will serve as output. So this is a very nice circuit. If you push down this one, signal will be there. So that's what we are expecting. But there is one challenge. When we push it down, it's connected fine. When we do not push down the button, are we getting this pin now is connected to just like should I say, it's not connected to ground, it's not connected to live. It's not connected to ground, it's not connected to live. So it will be giving random values, like somehow it will behave as if it's high, somehow it behave as if it's low. That's based on electrical noise. So we want it to really act well, like defined. It should be either high or low. Even when this button is not pressed, this guy should be either high or low, meaning it should still be connected to either low, which is a ground, or high, which is live. Now if we decide to put a jumper wire here and say, okay, fine, let's connect it to ground, so that when we do not push the button, it will be connected to ground. Okay, but when you push the button now, this signal that will go through has 2 different paths to go through, either this or this, causing another uncertainty. But of course, current flows through the path of least resistance and the shortest path, so it will likely flow through this side, which is not what we want. So instead, we'll put something that will allow current to flow through this other part. So we can put a resistor there. If you put a resistor there, hope you can see what I'm doing. From this part now, I put a resistor there. I connect the resistor to, connect the resistor to ground. So from here to here, there's a resistor. Meaning when I do not push the button, this part is connected to where? To ground through the resistor. That means the resistor now pull this thing now to what? Ground. So this is called what? It's a resistor, but because we use the resistor to pull down, to pull this this connection, to connect this thing to ground, it's actually, now we can call it a pull down resistor. If we use this resistor to connect it to a live, is what? Pull up resistor. So now, meaning if we do not push the button now, what we are going to get is what? 0 volts at this point, meaning low. So we have used this. Now you can call that a pull down resistor. So by the time we push down the button now, we now have current flowing in this direction. So the current has either to go through this way or through this way. But based on the fact that this is a resistor, it will resist the current to flow to this side. Current flows through the path of least resistance. Since you have resistance here, current will likely flow through this side, which is what we want. Please, if you have to take the video back to listen to that thing again, do that. When we push down the button, current flows through this side, and because there's a resistor here, current will now flow through this side, which is what we want. When we do not push down the button, the only part is that this is connected to ground through the resistor. So what I have here is a 10 kilo ohm resistor. The higher the resistance, the more likely current the more likely we'll have the current flow through this side, which is exactly what we want. So this is not a 220 ohm resistor, it's a 10k resistor. Okay, which is better, which is of course better. So like this, we have our circuit already. Now we can go into writing the code to make this thing work the way we want. So I believe we understand this whole thing. I believe we understand this. Okay, so we are here in our Arduino Integrated Development Environment. So this is the program for the push button. Is that correct? Push button. Okay, so what we want to do, of course, we set it up, and then we run the loop. I think we are aware of this already. Run the loop. So of course, in the setup, it's what? Void set up. Okay, so here we close set up. Look at what I'm doing. So of course, I just wipe out everything. If not, normally we are supposed to see a void setup and void loop right there. I just wipe out everything, so we go from scratch. So close loop. All right, so let's go. Now, before opening the setup, the variables we are going to make use of. Instead of writing 13, we use, I think I said this in the last video, no need to go over this. Instead of writing 13, we use what? LED. Okay, so we say anywhere we see LED, pin 13 is there. But this 13 is what? An integer, so we say int. I think we did something like this in the last video. So then which other thing did we make use of? Which other components? We made use of the push button, and we connect it to where? Pin 2. So that means push. We're trying to spell the whole thing. Let me just use push B. Okay, so push B. And of course, this 2 is an integer, so we are using int. There are other complex reasons, but let me just leave that for now. So in this setup, we'll now set up the Arduino, like how we connected the Arduino. So the way we connected it, the LED is what? Output, right? So this is the mode for it. So we can now say pin mode is what? Output for the LED. But for the push button, the pin mode for the push button is what? Push B is what? Input. Okay, so we've done our setup for now. So we'll close the setup. Now in our loop, that means the part that will repeat itself. When you push press the push button, we want that value. Like, how do we know we've pushed down the button? We have to read it now. So you say what? And that button is a digital button. It's a digital pin. So you say digital read. What are we reading? The push button. Are we following? So you will read the push button. But when you read the push button, you have to save it inside a variable. You have to save it inside something. So let's save it. Let's call it states. So states, meaning the state of the button. You can even write it state of the button, but that will be too long. So states. When you push down the button, this function will read what we have done, whether it is high, that is we've pushed the button, or it's low, we've not pushed the button. So it will read it. So when you read it, you now save it in the variable state. Let us come and declare that in here. So let's say state, int state. So let's leave it at that. I only declared it, I did not give it any value. The value will be given at this point. Okay, so now we can say if state equal to what? High, that means it's on. If the state equals to high, that means you actually push the button. What is going to happen? Now we can now say turn on LED, which is actually what? Digital write. Right, then we can say LED what? High. Are we following? Now, else, that means if the thing is not high, if the state of this thing is not high, meaning the person actually did not push the button, low. So if the state equals to high, if the state is high, you turn on LED. Else do what? Else just digital write will do what? LED should be what? Off, which is low. Okay, so guys, we are done with this program. So now we can run this thing. Let me connect it and then okay, so let me connect it. My previous program is still inside. Boy, it's coding. Let me see what's there. This guy back a bit. Okay, so let me load it. So when I click the upload, I think that's going to go in. Let's wait and see this thing blink. Alright, so it's set now. So now when we push this button, we should see it light up. Perfect. Okay, working perfectly well. Now notice this thing. You see this guy, eh? If I take out this pull down resistor, you are going to see the effects, how it's going to behave now. So now see, you observe the delay. Look, it's on, right? When I take my hands out, it will delay, like not knowing what to do. But when we put back the pull down resistor, which is just a resistor, but because we are connecting it to ground, it's actually pulling down. Watch, sharp. You see the sharp difference. Okay, now coming back to our code, if we decide to say if the button state is what? Low, that means we do not press the button. That is when the LED will be what? High. If we decide to do it like that, you will see the difference when we turn on the program. Else it should be what? Low. Meaning when we do not push the button, it will be what? On. When we push the button, it will be what? Off. So let's go. Let me upload that one quickly. One battery. Alright. Perfect. Now you see we've not pressed any, we've not pushed the button. We've not pushed the button, but it's already on. Now, just like the logic, meaning that when if the state is low, meaning we've not pushed the button, the LED will be what? On. If we push it now, else it should be low. If you push it now, it's going to off, turn off. Okay? Man, this is interesting. Alright, so that will be all in this video. That will be all. So thanks a lot for watching. Like, share, subscribe, and I'll see you in the next video. Bye for now.